Okay, so good morning. Welcome to this lecture. Now, last time we looked at determinant and we did, I don't know, 2 by 2, 3 by 3. So today we'll talk about how determinant is affected by the row operations. And just opening the page. Now, we'll talk about row operations. I don't know if you remember, but we used to have, they're normally called the elementary row operations, which basically just means that when you're solving, remember, when you're doing elimination method for solving systems of linear equations, you used to, I don't know, remember, you interchange rows or multiply a row or a column. In this case, we include columns by a non-zero scalar. And thirdly, you used to be adding or subtracting a multiple of a row to another. All right. So we look at how that affects the determinant of a matrix. And I would prefer to work with an example, and then later on, of course, you can generalize if you want. So consider matrix A, which is 1, minus 1, 2, 3. And of course, the determinant of this matrix is just 1 times 3 minus 1 times 2, which is 3, minus 2, which is 5. So the determinant of this matrix here is 5. Now, let's now apply these row operations and see how the determinant is affected. So first, we create a matrix B, which is basically interchanging the rows. So row 1, which is 1, 2, becomes row 2, and row 2 becomes row 1. So this new matrix B is just a modified that way. So what's the determinant of this matrix? You can see the determinant is minus 2, minus 3, which is minus 5. So what can you say? The determinant is 5 originally. When you interchange rows, it becomes minus 5. So the sign changes. Whenever you interchange a row or column, the sign changes. That means if now we create our old matrix from B, that's A, the matrix will change the sign to positive sign. Now, see what happens when you interchange columns. If you interchange, I don't know, the original matrix, this first column, 1 minus 1, becomes the second column. And the 2, 3, which is the second column in A, becomes first column when you get a new matrix C. So what's the determinant of the new matrix? It is minus 2, minus 5. So the same thing happens. If you interchange a row or a column, the sign of the determinant changes. All right. And here I say interchanging rows or columns negates or changes the sign of the determinant. So that's the first row operation. Interchanging rows changes the sign of the matrix, of the determinant. And then number 2, now multiply a row or a column by a non-zero scalar. How does that affect the determinant? Well, multiply row 1 by 2. Now, row 1, again, we're using this old matrix of ours, A. And if we multiply this row by 2, we get 2, 4. And then we keep the old row 2 as it is. So what happens to the determinant? You can see the determinant here is 6 minus 4, which is 10. So the determinant has been multiplied by 2. So you multiplying a row or a column by a factor multiplies the determinant by that factor. You can see the same thing for column here. Okay. Yeah, now I want to close this one. I go to the next one, page 1, page 2. Page 2 is, wait, we didn't say what happens. Okay, number 3. Yeah, I didn't talk about number 3. So number 3, what happens when you add or subtract a multiple of a row to another? And here it is. So multiply row 1 by 2 and add it to row 2. So basically, our old matrix A, you go and apply this row operation. You keep row 2 as it is. So our old matrix is this one. Row 2 is minus 1, 3. So it's minus 1, 3. And now add, so modify, create a new matrix F by multiplying row 2 by 2 and adding it to, no, row 1 by 2 and adding it to row 2. So you can see this will be twice this guy. It becomes 2, 4 here. Then you add it to the second row, and that becomes our new row 1. So you can see times 2. So 2 minus 1 is 1. And then this 2 we multiply by 2, it becomes 4 plus 3 becomes 7. So our new row 1 of the new matrix is 1, 7. And then we kept the row 2 as it is. So what's the determinant of this new matrix? The determinant of the new matrix is 10, is 3 minus 7. So the determinant is now multiplied by 2. Why? Because we multiplied this by 2. All right. So if in a matrix or a row, if in a matrix, actually a row or a column is built like this, okay? So you go to row I and make your row I itself multiplied by a scalar, which you're calling lambda, plus any other row J multiplied by some scalar alpha. That is Ri is given by lambda times row I plus alpha times row J. Then the determinant also, it will be scaled by this lambda, the one that you modified, okay? Here we modified row 1 by 2, so the determinant is also multiplied by 2. So that's basically how it works. Let's see whether this is the same thing, page 2. Now, this is now an example. So we apply the row operations. We applied the row operations in order to obtain the matrix. No, we applied these row operations in order to obtain the determinant of matrices. In other words, what are we saying? You see, when you're given a matrix, imagine the matrix is 4 by 4, 5 by 5. It's a big matrix, and there are no zero there are no zeros anywhere. So we use the row operations to introduce zeros into the matrix, so that, remember, when you're expanding the determinant of a matrix, if the matrix has zeros in a row or a column, then you normally choose that row or column and then expand the cofactors along that one. In other words, what's the determinant of a matrix? The determinant of a matrix is given by, you choose a row or a column, get the corresponding cofactors of each entry on that row or column, multiply them by those entries, and add them up. If there are zeros, it limits your work, it makes your work easy. So let's look at a particular example. We start with a 2 by 2. Our matrix A is 1 minus 1, 2, 3. So what's the determinant of this matrix? The determinant of this matrix, of course, we saw is 3 minus 2 is 5. Now, we can introduce, before we just compute the determinant direct, we can actually bring in, we can introduce the zeros, and then we get determinant faster, okay? For a 2 by 2 case, it really doesn't make sense to do that, because already it's too easy. You just multiply this by that, and then subtract this by this. But suppose we do that, okay? So now, determinant of A, this is determinant of 1 minus 1, 2, 3, should be the same as, now, what do I do? I apply the row operation here. I change row 2 becomes row 2 plus row 1. So you see, this becomes 1 plus minus 1 is 0, 2 plus 3 is 5. So I have a new matrix whose new row 2, has been modified this way. You can see we only multiplied by 1. So the determinant of this old matrix should be the same as the determinant of this new matrix. And of course it is. Check, 1 times 5 minus 0. Now, suppose we did a column work. Here now, this is a mistake. This is supposed to be column. Suppose I modify this column. I say row column 1 is column 1 plus column 2. Is that what I did? Or what did I do here? No, I did the row operation still. I say now, instead of, it's actually not a mistake. It's correct. So, or we just modify the first row. We say row 1 will be row 1 plus row 2. Row 1 equals row 1 plus row 2. Then we get row 1 is 1 plus 0, 0 here. And 1 plus minus 1 is 0. And then 2 plus 3 is 5. So you have 0, 5. And then you keep row 2 as it is. The determinant of this matrix should be the determinant of the old matrix. And it is, because this is 0 minus 5, which is 5. Okay? Now, still on the same note, let's look at another matrix here example. I want to give you a big one, so I'm in a hurry here. So allow me to hurry up. So B is 1, 3 minus 1, 2. Now, we do column modification. So we introduce a 0, but where? Here. So we just modify column 1. This is column 1. We add it to column 2. So the new column 1 is column 1 plus column 2. So you'll have, this part will be 1 plus minus 1, which is 0. And then 3 plus 2, which is 5. And then we keep column 2 as it is. So you have this new matrix. And this matrix should have the same determinant as the old matrix. This is 2 minus minus 3 is 5, and then look at this, 0 minus minus 5. Determinants are the same. Now suppose we modified column 2. We keep column 1 as it is, 1, 3, and then we modify column 2. Column 2 is just column 1 plus column 2. Now again, here this remains the same because the coefficient of what we are modifying, you see we are modifying column 1, here is 1, so it won't change. Likewise, here it won't change. Had this been C1, column 1 equals twice column 1 plus, I don't know, column 2, then the determinant has been multiplied by 2. We would have to divide by 2. Anyway, that's that, okay? Finally, the last row operation, the one of adding or subtracting a multiple of a row to another. What happens to the determinant? All right. So here now, we still have our matrix, which is C, which is 1, 3 minus 1, 2. Now, this is what we're going to apply. All right. We modify 1. We keep row 2 as it is. So you can see C, the new matrix has 3, 2, 3, 2. Now, the old matrix, what we'll do now is I'll multiply this guy by 3, row 1, and subtract row 2. You can see if I multiply this guy by 3, I'll have 3 minus 3 will give me 0, which is that one. And then minus 1 times 3 is minus 3. Minus 3 minus 2 is minus 5. So if you apply this row operation, this is what becomes of row 1. But then how does that keep our determinant? No, because you see row 1 has been multiplied by 3. So that means we have multiplied our determinant by 3. So we need to divide by that 3. So we multiply by 1 over 3. So the determinant of this guy equals a third determinant of the new guy. Now, what's the determinant of the new guy if I hide this part here? It will be 0, 2, which is 0 times 2 is 0, minus 15 is 15. So you need to divide by 3. That's why it's 5 like that. Okay? And that more or less ends the way they work. So let's now look at a bigger example. I don't know. Let's see, drag these things down here so you can see. Now we have a bigger example. Hopefully we'll have time to look at it, but we shall, of course. I don't want to make the videos too long. That's part of why I do this kind of thing. Well, one moment. Let me just zoom out and see how it looks. Okay, it looks like that. Okay, so here now we have a big example. And then this example is actually what you had in the last lecture. You had this example. You are supposed to find the determinant of this matrix. The example we had was asking you to compute the determinant of A. Our matrix A is this matrix, okay? So the last time we noticed the same thing we noticed the last time. What is that? When you want to find the determinant, you check if there are entries that are zeros. Like here, you can see there's 0 here, 0 there, there's 0, 0, 0. You can see this row 1, 2, 3. Row 1 has only 1 0. Row 2 has only 1 0. Row 3 has 2 zeros, so that's a good candidate. Row 4 has only 1 0, so not nice. Now, column-wise, column 1 has 1 0, column 2 1 0, column 3 2 zeros, column 4 1 0. So what do we choose? You could either choose row 3 that has 2 zeros, or you could choose column 3 which has 2 zeros. All right? But now we have extra tools because we do have the expertise of, we can actually introduce zeros and somehow keep our determinant as we want it to be, all right? So here we have already noticed that. So now what I choose to do is I will do both cases. I will apply column 3, get the determinant along column 3, and then that will be case 1. So apply column 3. So I choose column 3 to find my determinant. You can see column 3 is this one here. But then I also apply a row operation that will help me. So what I will do is I want to keep this 0, this 0. So what do I do for that? I fix this row. So I fix row 1, fix row 2 in the row operations. That means row 1 equals row 1 in the new matrix. Row 2 equals row 2 in the new matrix. That way I'm assured that I still have these 2 zeros intact, okay? And then now what I will do is I introduce a 0 here. See there? I introduce a 0 there. How can I introduce a 0 there? Since I've fixed row 1, row 2, I'll make use of row 3. So how is that? I multiply this guy by 2 and then add the 2 guys. That means row 4 will be twice row 4 plus row 3. That way I get a 0 here. And that way I'll have 3 zeros now on this column, and that my life is become easier. So keep in mind that how that affects our determinant. So we fix row 1, so 130 minus 2, 130 minus 2. Row 2, 1201, 1201, we say those ones are fixed. And then row 3, we also keep it, by the way, since we're only modifying this one. So we have 0, 0, minus 2, minus 1, 0, 0, minus 2, 1. I think it's minus 1. Okay. And then now we apply the row operation for row 4. So row 4 is twice row 4 plus row 3. So we multiply this guy by 2 and add to this one. You can see this will be 0 plus minus 2 is minus 2. Okay, I'm here. Minus 2 plus this guy is 0. Then 2 plus 0 is 2. And then minus 2 plus 2 is 0. And then minus 1 plus 0 is minus 1. So our new row 4 is this one here. Then this new row 4, now please note this one I cancelled, well, because of expanding for determinant. But now the new matrix we have is 1, 3, 0, minus 2, 1, 2, 0, 1, 0, 0, minus 2, 1, minus 1. Basically, the first 3 rows are the same. They're fixed, okay? Row 1 equals row 1, row 2 equals row 2, row 3 equals row 3. Row 4 is this new modification. And now we are using column 3 to expand to get the determinant. So the determinant of this matrix is going to be minus 2, is basically this one. 0 times the cofactor of 0 plus 0 times the cofactor of 0 plus minus 2 times the cofactor of minus 2 plus 0 times the cofactor of 0. Now 0, I mean, they're just reduced to 0, so we just remain with minus 2 times the cofactor of minus 2. Okay, now remember when you're getting determinant, we need to look at two things. One, to get a cofactor, you need to look at position, which is given by minus 1 times the number position row-wise plus column-wise. So this guy, minus 2, is in 1, 2, 3, row 3, 1, 2, 3, column 3. So I have minus 2. Now I'm looking for cofactor. So I'll have minus 1 power 6. Why 6? 3, row 3, and row column 3. So 3 plus 3 times the determinant of the matrix you get by deleting the row and the column where minus 2 is. So when you delete this row and this column, you remain with 1, 3, minus 2, 1, 2, 1, and minus 2, 2, minus 1. All right, so this is okay, this is okay. Then minus 2 is this one. Now what you may ask is, why this a half? And then a half I tell you because, see, the old matrix, the determinant, is not equal to the new matrix determinant. Why? Because we modified by 2. Since we multiplied row 4 by 2, then this matrix without this a half is the determinant is multiplied by 2. So we need to divide by 2. That's why we have this a half. Again, this a half is because we multiply row 4 by 2 and added it to row 3. So now our new, so this matrix determinant equals the determinant, this determinant. Basically a half times this matrix determinant, okay? Now, next, here you may say, oh, but now maybe I made my life ugly or things like that. Not really, because now the next we can do, now we become experts in this row modification. So here now, I mean, you can see, you just need 0 here, and then you can get a 0 here, because these are 1, 1, minus 2. If I multiply this guy by 2 and add it to the third one, then I'll get a 0 here, a 0 there, and then that would be a nice candidate for getting our determinant. So these are the row operations we apply for that case. I fix row 3, so row 3 equals row 3, then multiply row 2 by 2 and add to row 3. Remember, that will scale the determinant, you'll need to divide by 2. Likewise, this guy I multiply by 2, so row 1 is twice row 1 plus row 3. Why? Because this will give me 0 here, 0 there, and then I can use this part for expansion. So the determinant of what we have will now be what? I have minus 2, minus 6, these ones I kept carrying them there, times a half, the half I have there, the old one. Then I have two halves. Why? Because of these 2 and these 2. So I have a half, and the older half. In other words, since we have multiplied row 1 by 2, and we have multiplied row 2 by 2, that means we have multiplied the determinant by 2 by 2. Okay, twice. So we need to divide by 2 by 2. And then now let's do the modification. So row 3 is minus 2, 2 minus 1. Then row 1 is twice row 1 plus row 3. So you multiply this guy by 2, you have 2 plus 2 is 0. Then 2 times 3 is 6 plus 2 is 8. Then minus 2 times 2 minus 4 plus minus 1 minus 5. So that's our new row 1. Then row 2 is going to be multiply this guy by 2, add to row 3. So you have 1 times 2, 2. Minus 2, 0. Then 2 times 2, 4. Plus 2, 6. 1 times 2, 2. Plus minus 1, 1. So this is our new matrix. And so now this determinant equals this determinant. And now we expand determinant using this column. Why? Because we have two zeros. So the determinant of this now 3 by 3 matrix will be minus 2 times the cofactor of this minus 2. So we have, here I have a half, that gives me a quarter. Then I have, well, this minus 1 power 6 is just 1, it's gone. Then minus 2 times a half is minus 1. So I have a quarter minus 1. Then minus 2 times the cofactor of minus 2. This minus 2 times is cofactor. Now, what's the cofactor? So we just have, what do we have? Well, this minus 1 times minus 2 is 2. Divide by 4 is a half, so I have a half. Then what's the cofactor of minus 2? Well, the cofactor of this guy, this 2 is in row 3, 1, 2, 3, and first column. So it's just minus 1 raised to power 4. That is just 1. So we just have our half times the determinant of the matrix you get by deleting this row and this column. So that's just 8 minus 5, 6, 1. This guy, when you find this determinant, just 8 times 1 is 8, minus 30 is 38. 38 divided by 2 is 19. And if you remember, if you go back to your notes, you'll find that the determinant of this matrix we had originally is 19. So there it is, ladies and gentlemen. Okay, fine. Now we can do the same thing along, remember I told you that, you notice this matrix has zeros, these two zeros or these two zeros. So we can now use row 3. So case 1 is done along column 3. Now case 2 is along row 3. So far so good? Yeah, I believe. Okay, so now let's apply row 3. So let's go back and see what happens. The matrix is this one. I'm just copying it. This is the matrix we have. So here what we'll do is we keep this 0. Well, remember what we did for the, if we're expanding along column 3, we kept this 0 fixed by fixing this row, this 0 also by fixing that one. So now, since we're using this row 3, we'll fix this column, and then do modification elsewhere. So let's go there. So case 2, choose or apply row 3 to expand the determinant. So for me to keep these zeros, what I will do is I fix column 1. So this 0 is there. So that means this column is the same. So I'll have, the new matrix will have the same column 1 as the old matrix. Likewise, column 2, because I want to keep this 0 here. And then now where do I do the modification? Well, a modification can be done here. Okay. So in this case, I chose to fix, I'm using these two guys. I want to introduce a 0 here or here. All right. So I chose to introduce a 0 here. So how do I get a 0 here? Since these two are fixed and they don't have no zeros, the 0 can come from this guy. So if I multiply this one by 2 and subtract, then I'll be good to go. You know what I mean? This is, if I multiply this by minus 2, then I'll have minus 2 and minus 2. So if I subtract, then I'll be good to go. So fix column 1, fix column 2, fix column 4. We are modifying this one to make a 0 here. So column 3 will be column 3 minus twice column 4. And that's it. So column 1 is 1, 1, 0, minus 1. Column 2 is 3, 2, 0, 1. Column 4 is minus 2, 1, minus 1, 0. Now, the new column 3 will be column 3 itself as it is. You subtract twice this one. So you multiply this guy by 2 and subtract from this one. So multiply by 2, you get 0 minus 4. It gives you 4. Then 0 minus 2 gives you minus 2. Then you have minus 2 minus 2. It gives you 0. And lastly, you have 1 minus 0 is 1. So the new column 3 is this one. And now, since we modified column 3 by just using column 3, we didn't scale it by anything else, only 1. So this determinant equals this determinant. In other words, the determinant of this 4 by 4 equals the determinant of this new 4 by 4. And you can see now this new matrix has 3 zeros in here on row 3. So the determinant of this matrix is just going to be -1 times the cofactor of -1. All right? And now, remember, cofactor is you consider two things. One is sign, and the other one is the magnitude. Magnitude just means you delete the row and the column where it is. And then sign is just -1 times the power of the row position plus column position. So here we have -1. Where is this -1? -1 is in 1, 2, 3 is in row 3, and then column 1, 2, 3, 4. So you will have -1 times -1 raised to 3 plus 4, row 3, column 4, times the determinant of the matrix you get by deleting this row and this column. So if you delete this row and this column, what remains is 1, 3, 4, no, 1, 3, 4, and then 1, 2, -2, and then 1, -1, oh, -1, 1, 1. So that's what you get. And now we have a 3 by 3 matrix. Again, we don't want to do a lot of computation. So we use row operations again to make our life easy. So here I can tell you, you just notice right away, on this column, you have 1, 1, -1. So if we fix this row 3, and then add this one to this, we'll get a 0 there. Likewise, we get a 0 there. And life is good. So let's do that. So fix row 3. So row 3 is row 3. And then row 1 is row 1 plus row 3. And row 2 is row 2 plus row 3. So if you take row 2, row 1 is row 1 plus row 3 is just 1 plus 1 plus -1 is 0. 3 plus 1 is 4. 4 plus 1 is 5. So you have 0, 4, 5. Next, you have this guy plus this guy. You get 1 plus -1 is 0. Then 2 plus 1 is 3. -2 plus 1 is -1. And then row 3 is row 3. So it's -1, 1, 1. And now we are good to go. Well, so we have well, we have this matrix now. And then what else do we have here that I have not said? Maybe I have said that cofactor. So this is -1. Well, now one other thing I've not told you, this is -1 and this -1. So that disappears, all right? We just have this determinant equals determinant of this guy. And now we expand determinant of this one. How do you get determinant of this one? Well, it's just using column 1. So it's -1 times a cofactor of -1. So where is this -1? -1 times is in column 1, row 3. So it's just going to be 3 plus 1, -1 raised to 3 plus 1, times the determinant you get by deleting this row, this column, which is 4, 5, 3 minus 1. So what happens here? We just have 4 times -1 is -4, -15 is -19. And then this is positive, and then it's negative. So -19 times 1 minus 1 is 19. So this is the same thing you obtained the last time. And this is good, ladies and gentlemen. Okay, so lastly, I mean, that's all I wanted you to know, how the row operations, the 3 of them, affect the determinant. And now you know, all right? So here I have an exercise for you to do. At the end of you watching this lecture, you should be able to solve these problems. So one is show that 1, 1, 1, the determinant of this matrix equals the determinant of this matrix equals the determinant of this matrix equals the determinant of this matrix without too much computation. Let me just give you some hint, I mean, to make your life easy. I want you to notice, you see, if you say the determinant of, well, let's start with this one. This matrix has the same entries, really, 1, 1, 1, 1, 1. So if you are to say you modify, let's say you fix this one and then modify the others, you can see, let's say I fix row 3, and then I introduce 0 here, I introduce 0 there. How will I do that? I just subtract from this guy. So if I subtract, you can see this will be 1 minus 1, 1 minus 1, 1 minus 1, and that's 0, 0, 0, 0, 0, 0. So what does that mean? The determinant will just be 0 times the cofactor of 0 plus 0 times the cofactor of 0 plus 0. So the determinant of this guy is 0. Ha! Okay. Now, all it remains is for you to show that the determinant of this guy is 0, of this guy is 0, of this guy is 0. And that's not too hard for you to do. Okay, so you do that, all right? And then lastly, so that the video is half an hour exactly, this one looks complicated, but I want you to check in terms of which matrix is a multiple, which row is a multiple of an arrow. For example, row 1, 1, 0, 2, 4, 1, 0, and the last row, they are almost the same. The only difference is here. So you can apply that row operation. That will give you many zeros. Then will make your work easier. So it reduces to a 4 by 4. And so on. Or you can look at columns. If you look at column wise, I don't know whether there are any columns that behave the same. No, no columns, but 245,762, 245,362. Again, that can give you a nice row operation. So think about this and work on them. I believe you should be okay. All right, ladies and gentlemen. I want to stop there. I believe we are good to go. So let me just stop it. So stop